Welcome back to Introduction to Windows Server 2012-2016 Administration. My name is Scott Neal, and today we are going to be looking at Lesson 2 Post-Installation Tasks. Now that we have built our Server 2012 Windows Server, whether we built it as a virtual machine as we demonstrated in our earlier demonstration, or you're building it as a traditional server in a physical environment, there are some post-configuration tasks that should be considered when we first start the server up for the first time. So today I would like to talk a little bit about what those entail, and in the process we're going to cover exam objective 1.2 configuration settings if you're following along in the 70-410 book. We're going to be looking at typical post installation tasks to be considered really after any post installation in the Windows Server environment. We're going to talk a little bit about Server Manager also today. We're going to introduce you to Server Manager, give you a brief tour, particularly in the demonstration phase of today's lecture, because we're going to be using Server Manager a lot over the next few weeks in our course. It really is the tool to effect a lot of change on the server itself. We're going to also gain a little further understanding today on what the differences are between roles, features, and services and how they affect change within the server environment. We're going to be talking about adding and removing server roles today. We're going to be looking at converting between the graphical user interface and the server core, a new feature that came out with Server 2012 and Server 2016 that gives us the best of both worlds when it comes to the GUI and server core. We're going to, last but not least, in our lecture today, discuss what PowerShell is and discuss a little bit about desired state configuration. We'll go maybe a little above and beyond what the book does for desired state configuration. So let's go ahead and get started. So you finished your server install, you started your computer for the first time, and you're wondering what's next maybe? Well, you do realize, of course, that Server 2012, or the advantages of Server 2012, is that it really has taken remote administration to a whole new level. Most of the administrative tasks in Server 2012 and 2016 can be managed remotely through a variety of tools, whether that's Remote Desktop, MMC, Server Manager. All of these tools are now geared towards remote management of multiple devices and grouping devices so that we can configure those devices and maintain them. However, we are, when we first start up a box, obliged to do some post-configuration tasks on that box to ensure that we have that remote connectivity, and maybe go ahead and get started with setting up that box to perform the function that we have initially decided that box is going to do for us. So what are some of those tasks? Well, we're going to want to, for one thing, configure our network settings. We're going to be thinking about setting up a static IP address for the box, whether or not we're going to be using NIC Teaming for the box. We're going to want to set the time zones for the box. We're going to want to go ahead and adjust the computer name and decide if we're going to put the computer on the domain. We're going to turn on Remote Desktop, make sure the firewall is enabled for Remote Desktop so that we can start using those remote administrative tools on our server. And last but not least, we may want to take a look at the Windows Update settings, make sure that they're not set for automated updates. We'll talk about why that's not necessarily a good idea a little bit later. So, static IP addresses. Most of you are probably aware that there are really two ways in Windows environments that we can assign IP addresses to devices on our network. The most common way that we associate with workstations is DHCP, Dynamic Host Configuration Protocol. DHCP requires a DHCP server on our network, and we assign a scope of IP addresses, a range of addresses as it were, that we could lease out to these boxes for a certain period of time, but the default is 1 week, but we can certainly change that. In my lab I set it up for 1 hour. But anyway, we lease those IP addresses out because we have a finite number of IP addresses that are available to us, and we may have more devices that we have IP addresses. So we may want to lease those devices an IP address to make sure that every device, when they come online, has the ability to function correctly on the network. That's one of several reasons why DHCP is advantageous in those environments. DHCP is pretty much the standard when working with workstations, unless you just have lots and lots of IP addresses. If you're a Class B or a Class A network, maybe you're a large college with a Class B network and you got 55,000 nodes, you may want to assign them all a static IP address. That's fine. That's certainly up to you. If you got the IP addresses, use them. But most people are not that fortunate. So DHCP really works best, and it's also easier to maintain from an administrative standpoint because you don't have to figure out what IP addresses have been issued and keep track of that. So there are advantages and disadvantages to using static IP addresses in the workstation arena. However, for servers, it's a little bit different. Static IP addressing does give you one decisive advantage, and that is it is a more reliable way to access the server. For example, if my DNS goes down on my network, maybe I need to connect to my DNS server to fix it. But if that IP address for some reason is DHCP enabled, I have no reliable way of connecting to that server to effect change, because my DNS is down. Using the DNS name for the box will not get me into the box. So that means I'm either going to have to physically go to the box and work on it, or if I've used static IP addressing, I have that IP address written down somewhere. Even though DNS is down, DHCP is working fine, and I should be able to connect to that box using my IP address for that box and get into the box. So there are some decisive advantages to using static IP addressing on servers. This is particularly important, and most admins will agree that any server that's providing some sort of domain service or connecting to the internet should always use a static IP address. There is a point of contention. If you look out on the internet and ask the question DHCP servers, you'll see that there are discussions about whether or not DHCP is acceptable in certain instances of server administration. And I have read several of those arguments over time. They make some valid arguments, but my personal preference is go ahead and assign static IP addresses to all servers in your network. Chances are you're not running 300 servers in your network. You're probably running, at the most 100. I have seen some organizations that are running 1,000 or 2,000, but they're very large organizations and they have the IP address schemes to make it happen. But static IP addressing more often than not is going to save you a lot of grief, particularly if you need to connect to the box. You've got that IP address mapped out or stored in a logbook somewhere, and you know that you can reliably connect to it. There are some things to think about when you're going to be assigning static IP addresses, however. If you are doing like a lot of admins do, they put a device on the network, they plug it into the network, it gets an IP address, and they say, fine, I'll make that my static IP address. That's kind of the lazy man's way of doing it. It's a very quick way to do it. It's got connectivity now, and it should have connectivity from that point forward. But that IP address is an IP address that has been assigned to it through DHCP, so it is part of the DHCP scope of leased addresses. And that means that you're going to have to go into your DHCP server and you're going to have to block out, or what we call reserve, that IP address for your server. And that's going to require getting the MAC address of your server and writing down the IP address and making a reservation manually in the DHCP server, and of course manually entering that static IP address in the server itself. As long as these two things are done, then there's really no reason why that IP address should ever get leased to another box in the event that your device has gone down for any period of time. Maybe if it was DHCP and you hadn't taken it out of the DHCP server, then there's a remote chance that that device may get, or IP address may get released. We don't want that to happen. Another alternative, of course, is to have a scope of IP addresses that sit outside of your lease scope for such purposes as to assign to printers and servers and so on. that's fine too. If it's outside of the DHCP scope, it should never be leased, and you manually put it in there, and it will ask for that IP address, and the server will give it to it. So either one of those two options is acceptable. It really is up to you how you want to manage those devices. Ultimately, though, my personal preference, static IP addressing is the way to go for 99.9% of the time when it comes to servers. All right, NIC teaming. So while we're in there changing our adapters, setting up static IP addressing or whatever we're doing, we may want to think about NIC teaming. So NIC teaming really is a new feature that Server 2012 has come out with that really allows the combining of multiple network interface adapters that will allow us to increase bandwidth performance and fault tolerance on the device. There are really two modes that are available in NIC teaming. Switch independent mode. This is where all the network adapters will be connected with different switches, and that will give us a certain level of fault tolerance for that device. So if one of those switches goes down, we know that the other switch should pick up the slack and still have connectivity for the device, and therefore our users will remain satisfied with us because they haven't lost their data or connectivity to the server. There are two configurations available in switch independent mode. The active configuration really just means that all the adapters, when you put it in the NIC team, will remain active, and they'll share some of that bandwidth, the increased bandwidth throughput, giving you a little bit better performance. However, if one of the adapters does fail, you will see a performance hit on the machine. The other option is active standby, and it's just like it sounds. One of the adapters will be offline, the other adapter stays online as the primary adapter, and if that primary adapter ever fails for whatever reason, the standby adapter will become the primary adapter and it will continue on. This type of setup does not see a performance degradation because essentially you're accepting the same amount of bandwidth whether it's one adapter or the other. So those are the two types of configuration options that are available to you in switch independent mode. Switch dependent mode, if I have say servers in a rack and I only have one switch in the rack, or I'm really looking to increase or combine bandwidth, switch dependent mode may be the option for me. This is where all the network adapters are going to be connected to the same switch. That's going to allow me to combine bandwidth and increase the bandwidth throughput for the device. Particularly useful if I've got many users that are connecting concurrently to the server, downloading data, or they're using roaming profiles or something along that line. I know that the requests are going to be serviced in a timely manner because I've made some configuration settings that are going to re-optimize the bandwidth for the server. So NIC teaming is an option that is available to you. Now, if you're going to be using a server like we plan to do in our course, if you're going to be using a server and you're going to be setting up Hyper-V and running virtual machines on that Hyper-V, you're going to have to remember that one of your network adapters will be required and to be reserved for the Hyper-V virtual external switch. So just think about that if you're looking to do NIC teaming, that NIC teaming on a two adapter server using Hyper-V is really not feasible because that Hyper-V will commandeer that network adapter for its own use. Alright, enough about NIC teaming. Let's talk a little bit about switching between the graphical user interface and server core. In our last lesson we talked about how wonderful it is that Server 2012, unlike Server 2008, really allows us to do dynamic switching between server core and the GUI interface. With Server 2008, we introduced the concept of server core to reduce the size of the security footprint and resource overhead for a device. Great if I'm running a device with that's really pushing the minimum recommended settings for that device, but I still want to put Server 2012 on it. Server Core is a good option for that. problem with Server Core, of course, is that it requires you to do everything at the command line level, either on the command line itself or through PowerShell. Most of us IT admins, admittedly, are pretty rusty when it comes to doing stuff at the command line. If we're Windows IT admins, we've been kind of spoiled by that graphical user interface. So if we were running Server 2008 and we were running Server Core and we decided that Server Core just really wasn't working for us, then we were really left with no other option except to do a complete uninstall and reinstall the operating system and all of the components for that server, effectively putting us back to square one on that server in order to get the graphical user interface up and running. So Server 2012 and Server 2016 have eliminated that obstacle for us. So we are now in the position where we can, through the PowerShell, affect change with the GUI or Server Core. So if I want Server Core, I can go in and remove that feature, the GUI feature, and then if I decide later on that in Server Core I want to add the GUI interface back on, I can do that through PowerShell. We'll demonstrate that today as part of our demo mode. Okay. What else? Well, remote desktop, of course. Most servers have remote desktop enabled. Most IT admins really prefer to use remote administration for servers. Servers, of course, are locked in big scary rooms somewhere or a data center somewhere, making it difficult for us to stand in front of the machine anytime you want to affect any kind of change to it. So we use tools like Remote Desktop or MMC or Server Manager to affect change remotely from the comfort of our office. But in order to do that, we do have to enable Remote Desktop. Remote Desktop, of course, is not to be confused with Remote Assistance. Remote Assistance really allows a two-way relationship between a user at a workstation and an administrator to troubleshoot or to train or to demonstrate something. So Remote Assistance is a great tool in and to itself, but Remote Desktop really is all about administration. It allows us as administrators to log into any machine remotely, and it will eliminate us from having to stand physically in front of that server at all times. It's really kind of like just standing, you're looking at the machine's desktop right on the screen of your own office workstation. Very, very comfortable if you've never used Remote Desktop before. We won't demonstrate that particular tool today, but we will later on in the course. We should always really turn on Remote Assistance as a post-installation configuration task in the System Remote Settings menu, or we can do it through the Server Manager tools as well. Joining a domain? Well, chances are the answer to that is yes if you're a server admin. 90+% of the corporations and organizations out there in today's world run some sort of Windows directory service. A directory service really allows for the centralized mapping, organizing, and administration of networked resources. It does this really through a series of databases. Those databases are stored on a server in and to itself that we call a domain controller. We're going to be building a domain controller as part of our course for this lecture series later on, next couple lectures as a matter of fact. The Windows-specific directory service is known as Active Directory. So when you hear us talk about Active Directory services, we're really talking about running a directory services. Now, network resources are going to be grouped into what we call domains. Scottsbooks.com is an example of a domain. In that case, you're probably thinking of a registered domain that's available on the internet, but we can certainly create a domain for our internal infrastructure. It doesn't have to be registered on the internet. Of course, if it's not, it means we can't really connect to it from the internet or from outside of our resources in our network. But many organizations do set up domains for infrastructure management all the time. That's what we're going to do for our course. If you're administering a domain, however, you're going to need to give your system a unique computer name. That is a requirement that all resources on the domain have unique names, and you're going to add it to the domain and authenticate it to the domain using your domain admin or credentials that will allow you to add systems to the domain so that it can be managed appropriately. We typically will take a device, whether it's a server or workstation, and we'll group it with like devices, and that will allow us to centralize management for those devices and configuration settings and so on. And if you've never worked with domains, trust me, by the end of this course you will learn a lot about Active Directory. Most servers do belong to domains. We're not going to add our server to a domain today simply because we are going to make it a domain controller, and it will be the domain controller for a domain. So that's what domains really are. This is kind of a very high level discussion of domains. We're going to talk about domains and Active Directory in much more detail in the following lectures. Alright, installing roles, features, and services. I mean, really, a server ultimately is going to be a function of the roles and features that I've installed on it. So as we noted in the first lecture, roles really are a combination of all the components that when installed are going to implement one of the three types of services, whether it's a directory service, an infrastructure service, or an application function for our users to enjoy or benefit from. Features, on the other hand, are going to be much smaller modules. They are usually built with a single purpose in mind, and they tend to be installed to extend the capabilities of the operating system itself. Services, last but not least, are really programs that are going to run continuously in the background. They're always listening for incoming client requests. They're providing some sort of server functionality. And oftentimes we may opt to disable unwanted services that may have been built or turned on at startup as a default configuration for the operating system. By disabling unwanted services, we can indeed improve security and performance on the box. Roles, features, and services, of course, can all be managed from the server manager or remotely through MMC or some other tool. PowerShell is really, PowerShell has been around in the Windows world pretty much forever. It is a task automation and configuration framework that's integrated into all of the Windows operating systems. PowerShell is built on the .NET framework. So when you hear people talk about .NET, they're really talking about the coding responsible for the large class library where all of that code is stored and can be used or even reused by dissimilar programs to affect or change behavior on the machine. The computer interfaces with PowerShell using a command line shell. So everything that we do with PowerShell, we're going to be doing at the command line. When we created, or when Microsoft created, not me, but Microsoft created Server 2012, they had to add 2,500 new commandlets to extend the needed server operations for the new server operating system. PowerShell is a topic we're going to be discussing from time to time in other lectures. We're going to give you a basic introduction to PowerShell today. So last but not least, desired state configuration, or DSC. What is DSC? Well, if you've been reading the Server 2012 R2 70-410 book in Lesson 2, DSC is just basically mentioned and really doesn't do a very good job explaining what it is. So I wanted to take a moment to kind of elaborate a little further about what DSC is. DSC allows admins to create some sort of a standardized server configuration, which PowerShell then takes the responsibility for deploying to all of the affected nodes within the environment. There are a lot of advantages to using desired state configuration. For one thing, it simplifies your administrative tasks by allowing you to configure one or more devices automatically. Once those devices are configured automatically, DSC is responsible for ensuring that that machine's configuration will not be altered from its initial configuration until you've decided otherwise. Machines, of course, using DSC, that means that machines that you have decided to be configured a certain way will all be identically configured to those configuration settings. So you group of machines or workstations together, you come up with a configuration template for those machines, and then you deploy it to those machines for the purpose of simplifying and automating your administration for those boxes. Great thing about it is that I can use DSC on a large scale. I can deploy over the network or over the cloud with DSC. So DSC really allows us to standardize to a large degree our IT environment. There are two modes that are available with DSC. The push mode allows me to build a device that will be a DSC device designed for me to make configuration changes on, and then I have the ability to push those changes out to those affected devices on the network. Push mode is generally considered a one-direction communication. So it communicates, it touches those devices, it tells it to alter its configuration settings, and then it's done. The other option is the pull mode option, and pull mode is pretty much just the opposite of push mode. Instead of me pushing out or using a device to initiate the push out of configuration changes, it is up to the devices on the network to contact the server in question using the DSC deployment methods to ask if there are any new configuration changes that it should adopt. Then the DSC server will confirm or deny those changes for those devices, and then if there are configuration changes, it will then push those devices out or tell those devices what those changes are and allow them to be pulled down by the devices themselves. This is definitely a two-way communication, and there are advantages to push mode and pull mode and some caveats of each as well. This is probably not the lecture to talk about DSC in great detail, but when you think about DSC, think about things like SCCM, group policy, Windows server update service, and things like that. These all are tools that allow for standardized configuration of our network. DSC, or desired state configuration, really is the component in PowerShell that allows for that configuration process once we have made our determinations of what those configurations are. DSC is what ensures us that PowerShell will take those configurations and deploy them reliably. So when we talk about desired state configuration, that's really that's the crux of really what DSC is all about. We're going to look at some examples of DSC perhaps later on in our lecture series. So, quick summary. Servers must be configured after the installation with the proper roles and features to accomplish the tasks that you have set out for. Alright, so lesson summary. First of all, in order for servers to do what we want them to do, we need to configure them after the installation with all the proper roles and features that we want to accomplish the desired tasks that I've originally set out for it. I'm going to want to set up a static IP address because for most servers it's very crucial to ensure reliable connectivity. I'm going to want to configure and optimize services for my device in order to increase the functionality while reducing its footprint and optimizing the resources on the box. I also may want to use NIC Teaming as a means of increasing the network throughput for busy boxes, or for providing additional fault tolerance on boxes that need significant uptime. Make sure that if I've got a health record server or something like that and it's a critical infrastructure device, NIC Teaming can help me provide some additional fault tolerance for that particular server. Last but not least, we can further reduce the resource overhead and security footprint by turning off the graphical user interface of the operating system itself, knowing that if we need to turn on the graphical user interface itself, we can do that through the PowerShell options. So, why don't we go ahead and do a demonstration of some of these post-configuration tasks and introduce you to PowerShell before I finish the lecture for today. You can see I've gotten the box back up after we've done our install. I'm going to do a Control-Delete, and I'm going to log into the box. And you'll see that the graphical user interface has been removed from the box. So this poses a problem. This is the command line interface here for the box, and this is what you start with when you're in Server Core. There is no graphical user interface installed anymore. So if you're an administrator and you're like me, you're probably not comfortable using the box in the Server Core mode. So what can we do? Well, let me show you how we can restore the GUI features for our Server 2012 box. Let me just show you just how easy that is. First of all, we're going to need to go into PowerShell. So I'm going to type PowerShell, like so. And then I'm going to type this command here, install. Infra, comma, what am I installing? Server, GUI. The command line, of course, is not very forgiving if you make a mistake. So we're going to also, I'm just going to do this for now, GUI, and we're going to see if it will build that GUI infrastructure for me again. So see, we're actually beginning to move up. We're at 24% complete. As you can see, PowerShell is indeed rebuilding the graphical user interface for this server. Excellent. So this process will take just a few minutes, and then we will have a graphical user interface right back where we started from when we built the box to begin with. Okay, thanks to the magic of video recording, we have now installed the GUI interface, but now we got to do a restart of the system. So how can we do that at the command line? We're going to say shutdown -R -T for time, and the time is going to be 0. There we go. Alright, so we're going to be installing those features now. Okay, so we are restarting, and hopefully, if all has gone well, we have installed our GUI interface for our demonstration today. So let's see what we got going on here. Okay, we are back at our login screen. So the system has shut down. It's reinstalled the GUI interface features for the machine. So now if I do Control-Alt-Delete, hopefully when we get back into the box here, we'll see that we do indeed have the GUI interface reinstalled for the box. Most excellent. Server Manager is now starting up. Server Manager will by default start up anytime you log into a GUI enabled 2012 R2 server or 2016 server. So Server Manager, we're going to be playing in Server Manager a lot for the next several lectures that we're going to be doing in our server installation series. So what we're looking at right now is dashboard. I'd like to give you a quick tour of the server manager, if I may. The dashboard really just gives you a very brief synopsis of the roles and features installed on the server, as well as any events or services that need to be monitored either on the local server itself or on all the servers that are currently being managed in your server manager. I have the ability, if I go into the Manage menu here, you'll see I have the ability to add multiple servers to this dashboard, allowing me to manage servers all across my network. It's Server 2012 servers, Server 2016 servers, even Server 2008 servers with a little bit of finagling can be added and managed through this particular server manager dashboard. I can also create server groups. So once I've got those servers added, I can create special groups based on their roles or configuration settings, which will allow me the ability to manage those servers more efficiently. So as you can see, we have the ability to add roles and features or remove roles and features through the Manage utility also. We'll be doing some of that later on in some other how-to segments. Tools menu here, if I go into the Tools menu, you can see that just about any feature or any role that's been installed on the server, the management utilities for those can be accessed through the Tools menu. Everything from component services and computer management all the way down to the resource manager, the services, system configuration, task schedule, even Windows PowerShell itself can be started in the Tools menu. The View menu is very simple. It just allows me to go in and change the actual view settings for the server manager. If I want to add more detail or remove some more detail, or I'm having trouble seeing it, I have the ability to change those settings through there. If I go over here to the left-hand side menu, after we move from the dashboard into the local server, you'll see the properties box in the local server menu does give me the ability to make several changes to the local machine right from the properties menu. Things like remote desktop can be enabled simply by clicking on the remote desktop icon here and selecting enable or don't enable here. I can then add the users that I want, whether I'm adding a user or a user group to manage this server. That can be done through the remote desktop user's interface. Likewise, NIC Teaming, which is disabled, can be controlled here as well. Maybe I want to go in and I want to set up a static IP address. Well, I may have to go in and do CMD and set up my command prompt and go in and say IP config /all. And this is going to give me a very detailed list of my NIC cards. I'm going to get the physical address of the NIC card. This is very important for setting up my DHCP reservations. If I'm using an IP address like the IP addresses here, which were automatically configured, I would need to go into the DHCP server and set up a reserved address for those, and that's going to require a MAC address to do that. I can get the MAC address from the command line here, as well as the IP address that I'm going to be using, 192.168.0. I think I'm going to use 17, the subnet mask, the default gateway. All of these things will be necessary to do my static IP addressing. If I go into the Open Network and Sharing Center by right-clicking down here on the network icon, I can actually go into the adapter settings and actually set those up. Let's say I want to set up this particular NIC card here. I can do that simply by going in and saying use the following IP address and say 192.168.0. We'll say 16 for this one. 255.255.255.0 because that's the one for this one. And then maybe I want to set up my own special DNS setting. I can do that here as well. Not a requirement. I can make this automatic if I want to, but this is Google's DNS server, so maybe I'm not happy with the DNS server I've got set up, so I could do that as well. Simply hit OK. I got another one set up on this other NIC card, so that's why you see that warning. Hit OK again, and we're good to go. So what else can we do? By the way, I can reverse that process, and I'm going to do that, I think, for this particular NIC card as well. I'm going to go in here and go into Properties, and if I don't like to use the static IP address, I can simply set it back to automatic, like so, and we're good to go. Alright, so that's how you would actually set up a static IP address for your box. Likewise, I can go in and do NIC Teaming. So maybe I want to set up NIC Teaming, currently disabled. I can just simply click on the NIC Teaming icon, go into Tasks, set New Team Up, select the network cards that will be part of the NIC team, give it a NIC team name, and then select, I'm going to say switch independent for this, and it will save that new NIC team configuration for me. I can also do this at the command line. So if I have a problem with that, I can go in and do it at the command line and even get more specific with my NIC team characteristics. I'm going to go ahead and delete this NIC team right now because I'm going to be perhaps using this for Hyper-V. And if I'm going to be using a server for Hyper-V, then that second NIC card is going to be very important because I need to reserve it for my Hyper-V virtual external switch, which will take over the second NIC card on the machine. If I have more than 2 NIC cards, by all means I can use NIC Teaming as long as I save at least 1 NIC card for Hyper-V for the external switch. What else can I do in here? I might want to change the computer name. So this computer name right now is Scott. You can see I got Scott here with the workgroup test. This is just a description that will show up. Maybe in Active Directory I want to know where this box is located or something. I can simply put a description in here and it will show up for my IT admins to see. Ultimately, you change the computer name of the workgroup or domain by selecting the change menu here. And I can simply say I want this box to be Scott1 instead of Scott. If I wanted to add it to a domain, I can do that by selecting this, typing in the domain like scott.com or scott.org. And when I do so, I will be prompted for a username and password for that domain that will allow me to add this box to that domain. And once I do that, I will have to restart the system. It will say welcome to the domain and we're good to go. Alright, so I'm just going to leave the workgroup as workgroup test. I'm going to say OK. And it's going to prompt me to restart the machine just like so. Hit close, restart the machine, and when we come back you'll see that that box is going to be Scott1 instead of Scott2. So once the box rebuilds, should take just a minute or so. Alright, so now we're ready to log into the box again. So I'm going to put in my password. And we're going to log in, and when Server Manager kicks back up, I bet you that box will be changed to Scott. Let's see, local server. There it is, Scott1. See, the box has been changed. So, very simple process for changing the box there. So I've showed you how to turn on remote desktop, set that up. I've showed you a very brief introduction to PowerShell, how to get back into the GUI interface if you find yourself in Server Core. We can go in and turn off the GUI interface, just very simple through the Manage menu here under Remove Roles and Features. I can say Next, Next, Next. And then that feature that I'm going to remove is right here, this User Interfaces and Infrastructure feature. I just simply uncheck that box, select Remove, and we'll be right back where Server Core is. So, very brief introduction to configuring post-configuration tasks on your local server. We may want to go in and do some firewall configuration as well, depending on our firewall settings in our organization. We may want to disable or enable some firewall ports specific to our network parameters. We may have some specific services that we would like to disable at startup. We can certainly do that through the Task Manager. So there's several other configuration considerations to be dealt with here at the startup of our first box. When we come back, we're going to actually start looking at and building out this box as a domain controller. And I'm really looking forward to showing you that how-to segment, and we'll see you then. Thanks a lot.